Okay, here we go. Chapter 2, homework. All right. This is a pretty straightforward class. You should get this. Nothing challenging here. I will say that chapter 2 is challenging, but not lesson 2.1. All right. It's entitled If Then Statements and something called a converse. All right. This is not a class, not pay attention. It's a very simple class if you pay attention, but if you don't pay complete attention, you can get lost pretty quickly. It's one of those easy classes if you pay attention, but very hard if you don't. So super easy, but makes absolutely no sense if you don't pay attention. So pay attention. Here we go. Did you notice that in your book of truth, the things that you're writing down, that most of the theorems, 1.1, 1.2, 1.3, say if blah, 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 then something else. Notice that both theorem 1.1 and 1.3 start off with the word if, and then there's a comma, and there's a word then. We literally call those statements if-then statements. And you can kind of see why they're in red. They're called if-then statements. So let's write that down. So what is an if-then statement? We call it a conditional statement. If you meet the conditions, then something will occur. So it's a conditional statement that relates the hypothesis or a hypothesis to a conclusion. The hypothesis is the if part, and the conclusion is the then part. And believe it or not, we're going to be looking at sentences that had the word if and then and figuring out which is the hypothesis and what's the conclusion. Pause if you need to write this down. So the statement itself is called a conditional statement. And we have, as always in mathematics, we have a shortcut method of writing this down. So instead of writing that complete definition for an if-then statement, we say if P, then Q. P stands for the hypothesis and Q stands for conclusion. If P, then Q. P is the hypothesis and Q is the conclusion. All right, so let's see an example of that. If it's raining, then the road is wet. So clearly, this is an if-then statement because it starts with if. There's a comma. Comma is not critical, but typically they will have a comma. And then there's the word then. All right, so let's see. What's the hypothesis? The hypothesis is the P portion, and that's what happens after the word if. So the hypothesis in this case is it is raining. The conclusion, that's what happens after the word then. And what happens afterward then is the road is wet. So the conclusion is the road is wet. And it's literally that simple. In fact, the hardest thing is to remember what's the P and what's the Q. P comes before Q's, if comes before then. How about that? Here's another one. If x squared equals 25, then x is less than 10. Once again, for homework, they're going to ask you what is the hypothesis and what is the conclusion. The hypothesis is what comes after the word if, so x squared equals 25. And the conclusion is what comes after the word then x is less than 10. If-then statements. Of course, there's always a but, right? Language is not as precise as mathematics. Mathematics is objective and very precise, but language can be a bit subjective. So in fact, there's three buts here. So here are the three buts because it's written in English. You might have a conditional statements without the words if or then. You might have an if, you might not have an if, you might have a then, you might not have a then. So you might have a conditional statement, I'll show you an example, that has neither or it's missing one of the ifs or the thens. The but number two is sometimes the then part will be spoken before the if part. I'll show you an example of that one as well. And then lastly, a combination of both of those. You might not have an if or a then, and they might put the conclusion before they put the hypothesis. I'll show you an example of each one of those. Tonight for homework, they're going to give you a statement. You have to identify the hypothesis and the conclusion. So it may or may not have an if or a then. When it has an if or a then, it's pretty straightforward. But here are some statements where there are missing an if and a then. So it says, I like dancing when the music is slow. So what I always ask myself, what has to happen first? Do you have to like to dance first, or does the music have to be slow? And if we think about this as a timeline, the music has to be slow in order for you to start dancing, right? So what has to happen first, right? The music has to be slow. So that's actually the if part. If we were to write this as an if-then statement, if the music is slow, then I like to dance, if that makes sense. Okay, so that's an example where both the if and the then are missing and the conclusion happens before the hypothesis. So that was the but number three. Here's another one. Giving me money implies you want me to go get the pizza. Well, let's see. What would have to happen first? Do I get the pizza first or do I get the money first? So if you're going to get pizza, you always want to get the money first because you're not going to you're not going to buy the pizza for someone else. They're going to give you the money to buy it. So this is a case where we're missing the if and the then, but the if or the hypothesis does come first. So what has to happen first? I need the money. So if you give me the money, notice I'm putting an if there, then I'll get the pizza. Does that make sense? Okay. I do have one that's slightly, you can make an argument for this one. It says, when the car is running, it is burning gasoline. And I typically will have some student make a pretty good and valid argument of which one is the hypothesis and which one is conclusion for this one. I would say most of us would take this as meaning the car has to be started before it is burning gasoline. And so we would say the hypothesis is the car is running, and then the conclusion is then it is burning gasoline. I will say yes if you give me a dollar, right? And we're taking this from your perspective. I will say yes if you give me the dollar. So what has to happen first, right? This one has an if, it just doesn't have a then. So we're missing the then part here. But the hypothesis is if you give me a dollar, then I will say yes. All right. Oh, one last one. So, homework tonight is a mixture of some math statements and just some general statements. So here's a math statement. 4 plus x equals 5. 5 implies that x equals 1. Well, if you treat that as an equation that you must solve, well, you need the equation before you solve it. So if I solve that equation, then I do, in fact, find that x is equal to 1. So the hypothesis is 4 plus x equals 5, and the conclusion is that x equals 1. Okay, that's our first objective. All right. We literally in math have this concept called the converse, and the converse is the definition. It's a conditional statement. The difference is that we interchange the if and the then. We take the normal conditional statement, we leave the words if and then in place. We just swap the words that come after if and then. So it's a conditional statement formed by interchanging the hypothesis and conclusion of an if-then statement. The only thing you will not move is the word if and the then. All right, so if you need an example, here's your example, right? If P then Q is a conditional statement. So I'm going to leave the word if in the same spot. I'm going to leave the word then in the same spot. I'm just going to move the P and the Q. So the converse would be if Q then P. Remember, P is the hypothesis and Q is the conclusion. Right? So how does that work? What's an example? Here was our previous statement. If it's raining, then the road is wet. And we said that if it is raining is the hypothesis, then the road is wet. So if we swap those around, I'm leaving the words if and then, I'm just swapping the words. So if the road is wet, this would be the converse. If the road is wet, then it's raining. Okay? Let's do that to these other ones. Let's see. Originally, we said that the car, if the car is running, then it's burning gasoline. So if we swap those around, if it's burning gasoline, then it's running. So if Q, then P. Let's see. Originally, we said if you give me a dollar, then I will say yes. So if we swap that around, right? If I say yes, then you will give me a dollar. And lastly, this one, originally we said if 4 plus x equals 5, then it implies that x equals 1. So if we swap those around, if x equals 1, then it implies that 4 plus x equals 5. Got it? Okay. That was our second objective. Third objective. All right. So how do we prove a statement to be false? Tonight for homework, they're going to say these statements are false. Prove it. All right. So, for instance, maybe you've seen this movie, maybe not. Here's a statement: all dogs go to heaven. How would you prove that? Well, you'd have to prove that there weren't some dogs in heaven, right? And Greek mythology, Roman mythology, Cerberus, you get the idea. This is a joke, obviously, not math. All right. So, to prove a statement is false, right? We simply need something called a counterexample. So, a counterexample is a statement that disproves an if-then statement. In other words, it disproves a conditional. And we only need one counterexample to prove it to be false. If you um, tell your mother that you always eat your vegetables, and then one night you don't, well, then that disproves that fact that you always eat your vegetables. All right. So let's see. Can we prove this to be false? If the road is wet, then it's raining. Well, the rain could have stopped. The road is still wet, right? And it's clearly not raining. You could have had, if it's a dusty environment, sometimes they have these trucks that spread water on the ground, and that means the road is wet, but it is not raining. So we just need one counterexample to disprove the statement. So this is not a true statement. If the road is wet, then it's raining. If it's raining, then the road is wet, is a true statement. So remember, it only takes one counterexample to disprove. Tonight for homework, we'll say disprove the statement. You just got to come up with one example to disprove it. Okay, here's another example. If Ed lives in Texas, then he lives south of Canada. Well, that's a true statement. Texas is south of Canada. The converse of this statement, right? So the conditional, that statement in blue there is true. So, but what's the converse of that statement? So flip the if and the then around. So let's see. If he lives south of Canada, then he lives in Texas. And clearly that doesn't necessarily is true. We just need to come up with one counterexample. Let's see. If he lives south of Canada, he could live in California. And if he lives in California, he doesn't live in Texas. So there's your one counterexample to disprove that statement. Just because the conditional true does not mean that the converse is true, or vice versa. Just because the converse is true doesn't mean it makes the conditional true. So here's our statement. Is the conditional true if x plus x equals 6, then x is equal to 3. If we solve that equation, 2x equals 6, so x does equal 3. So the conditional is true, but is the converse true? So let's see, if x is equal to 3, then that implies that x plus x equals 6. Is that true? If x is 3, do a substitution, 3 plus 3. Well, that's true too. 3 plus 3 is 6. So here's an example where both the conditional is true and the converse is true. Once again, I'll state this again. Just because the conditional is true doesn't imply that the converse is true. I showed you one example where it's not, and here's an example where it is. Back to this one. Let's see. If the car is running, then it's burning gasoline, right? We said that that's true for the conditional. For the converse, if it's burning gasoline, um, um, oh, I'm sorry, we're just going off the statement, just the statement. Determine this is the converse. Sorry. If the car is running, then it's burning gasoline. All right. How about this? I will say yes if you give me $1, right? If you take that as the conditional statement is true, but the converse, if you give me $1, I will say yes. That part would be true, but that's not what this statement says right here. It says, I will say yes if you give me $1. And the last one right here, if 4 plus x equals 5, that implies that x equals 1. Yep, if x is 1, then 4 plus 1 does equal 5. All right, we're on to the last thing. All right, what is a biconditional statement? So let's say we take a conditional statement if it's true, and then we take the converse if that is also true, then you have something called a biconditional statement. In other words, both the conditional and the converse are true. Okay, great. It's biconditional. So what? If it's biconditional, by tradition in geometry or math in general, we use the magic words if and only if in the statement. So the only time you will ever see the words if and only if is for biconditional statements. Those are statements that both the conditional and the converse have been shown to be true, right? And it's only biconditionals that use the words if and only if. So here's how that works, right? Here's a statement. This is a geometry statement. If 2 points are on the same line, then they are collinear. Hey, that's the actual definition of collinear, so that's true. So the conditional is true. How about the converse? Let's see, what would be the converse? If 2 points are collinear, then they are on the same line. Well, that's true as well too. So both the conditional and the converse are true. Therefore, this is a biconditional statement. So tonight for homework, they'll say, determine if you have a biconditional. If so, write the biconditional. So what they want you to do is go back to the original conditional. That's the top statement there. And what they want you to do is they want you to get rid of the word if and get rid of the word then. So I'm going to find the words if and then. I'm just going to cross them out and I'm going to replace only the word then. So I'm only replacing the word then with the magic words if and only if. So let's see what it says now. 2 points are on the same line if and only if they are collinear. Once again, the magic words if and only if are only used for biconditional statements, and they have to be proven, both the original conditional statement and the converse. That's what makes them biconditional. All right. So 2 points are on the same line if and only if they are collinear. All right, let's see another one. Prove the statement is biconditional and then write an if and only if. All right, let's see what it says. It says segment AB is congruent to segment CD, then segment CD is congruent to segment or to congruent to segment AB. Well, that's true, right? What would be the converse? If segment CD is congruent to segment AB, then segment AB is congruent to segment CD, and that's true as well too. So both of the conditional and the converse are true, so we can write the if and only if or the biconditional. The steps are go back to the original conditional, that's the top blue one. Get rid of the word if, get rid of the word then, and replace the word then with if and only if. So segment AB is congruent to segment CD if and only if. Segment CD is congruent to segment AB. And that's how it's done. Cool? All right. So your homework will look something like this. They'll give you, for instance, they'll give you a statement and they'll say, provide a counter example to show that each statement is false. You'll have to think those logically true. And let's see, I'll give you an example here. So number 11, this is a classroom exercise. If x squared equals 49, then x is equal to 7. Well, that seems to be true because 7 squared is 49. But it also implies that -7 would make this true. So -7 squared, -7 times -7 is 49. So on number 11, provide a counterexample to show that each statement is false. It's not that x equals 7 is the false part. It's just there's another number that also makes it true. So it's not only that x is equal to 7, x is actually equal to 7 or -7. So you only have to come up with one counterexample. Okay? And then you'll have some statements like this. It says state the converse of each conditional. Is the converse true or false? You should be able to handle that with this. If not, rewind the video, watch the important part, come back and hit me up with some questions if you have any. If not, then I will see you in the next video.